Good morning, students. Now, the last class is practice problems. Now, these three problems are there. Okay, after that, solutions. Next, here binomial theorem or general binomial theorem, x plus y whole to the power of n is equal to, you know the theorem, right? nc0 x to the power of n y to the power of 0 plus nc1 x to the power of n minus 1 y to the power of 1 plus nc2 x to the power of n minus 2 y to the power of 2 plus so on ncn x to the power of n minus n y to the power of n, right? In general, again once again, x plus y whole to the power of n, binomial formula. X plus y whole to the power of n is equal to nc0 x to the power of n y to the power of 0 plus nc1 x to the power of n minus 1 y to the power of 1 plus nc2 x to the power of n minus 2 y to the power of 2 plus so on plus ncn x to the power of n minus n y to the power of n, right? That is a general binomial theorem. Here we are same thing we are writing here, 1 plus x whole power n we are writing, right? 1 plus x whole power n. Here x value is 1, y value is x, right? What is the binomial theorem statement? See, nc0 plus nc1 x to the power of 1 plus nc2 x square plus nc3 x cube plus so on plus ncn x to the power of n. This is binomial theorem, right? 1 plus x whole to the power of n formula. Now we know that this nc0 can be written as n0. This is a shortcut notation, or another notation, nc0 can be written as n0. The binomial expansion of 1 plus x whole to the power of n is equal to n0 plus n1 x to the power of 1 plus n2 x square plus so on plus nn x to the power of n. This means ncn, right? Now n1 means nc1. 1 plus x is an ordinary generating function for the sequence n0, n1, n2, n3, so on, nn, comma 0, 0, so on, right? This is the generating function for the sequence nc0, nc1, nc2, nc3, so on, ncn, right? Now if you want you can check this one, right? See, here 1 plus x in 3 2 first beginning of the chapter, for any set these are the generating function, these are the terms of the sequence. Here 1 plus x whole power n is called the generating function, right? Now here next ncr, this means nc, this standard notation is ncr, or you can write c of nr, and there are three notations are there. ncr can be written as n of r and c of n comma r, right? Now ncr formula is equal to rc of n comma r formula is equal to n factorial by r factorial into n minus r factorial, right? Now we are taking this one here, 1 by r factorial we are separating, n factorial by n minus r factorial can be written as p of nr. Now or else you can write this one. See, npr formula is equal to n factorial by n minus r factorial only. This is npr formula, whereas ncr formula is this one, n factorial by r factorial into n minus r factorial. That is the difference. Now if you separate this 1 by r factorial, n factorial by n minus r factorial can be written as npr, or you can write p of nr. What is p of nr? P of nr denotes the number of permutation of n objects taken r at a time, right? P of n and probability, that one. Next, 1 plus x whole power n formula. Once again, you are writing by using binomial theorem. nc0 plus nc1x plus nc2x square plus ncnx to the power of n. Where these are the coefficients. These are the coefficients of x power 0, x power 1, x power 2, and so on, x power n. No? Now this is a generating function for this sequence, right? Now a small difference is there. Now we are denoting this one by c of n comma 0. This one can be denoted by c of n comma 1, c of n comma 2 plus 1 c of n comma n. These are the notations. No, just now we discussed about these notations, right? Now here np of nc of nc0 is nothing but p of nc0. C of nc1 is nothing but p of n comma 1. Whereas the third term onwards, c of nc2. C of nc2 means nc2, no? nc2 is equal to 1 by 2 factorial into np2. Remember this one, right? C of nc2 can be written as p of n comma 2 by 2 factor into remaining thing is x square. Similarly, third term also we are writing. Here third term will be c of n comma 3. Excuse me. C of n comma 3. C of n comma 3 in terms of p means p of n comma 3 by 3 factorial into remaining term will be x cube plus so on, plus this one c of n comma n can be written as p of n comma n by n factorial into x power n. We are using this formula, right? Whereas NCR is equal to NCR, or you can write CNR is equal to this formula we are writing. C of NR can be written as 1 by R factorial into P of n comma R, right? Suppose if you want to calculate C of n comma 0, C of n comma 0 is equal to 1 by 0 factorial into P of n comma 0. See, this is the first one. C of n comma 0 is P of n comma 0, because 1 by 0 factorial is nothing but 1 only. That means C of n comma 0 is equal to P of n comma 0. Next, here second term C of n comma 1. C of n comma 1 is equal to P of n comma 1. No? Right. See, check here. C of n comma 1 is equal to 1 by 1 factorial into P of n comma 1. 1 by 1 factorial is again 1 only. Therefore, C of n comma 1 is equal to P of n comma 1. Right? Next, similarly, second one, C of n comma 2 is equal to, here the difference, see the difference. P of n comma 2 by 2 factorial into remaining term is x square. See, put n is equal to 2 here, r is equal to 2 here. C of n comma 2 is equal to 1 by 2 factorial into P of n comma 2. See, 1 by 2 factorial into P of n comma 2. Similarly, C of n comma n is equal to P of n comma n by n factorial. Right? Next. Now, for the sequence a0, a1 and so on, a3, so on, real numbers, a and real numbers, f of x is equal to a0 plus a1x plus a2x square by 2 factorial plus a3x cube by 3 factorial can be written as by using summation. See here, I running from 1 to infinity, ai into x to the power of I by I factorial. If you put I is equal to 0, a0 into x to the power of 0 by 0 factorial. That means a0 you will get. If you put I is equal to 1, a1 into x to the power of 1 by 1 factorial, second term. If you substitute I is equal to 2, a2 into x square by 2 factorial, third term, and so on. This is called exponential generating function for the given sequence. Right? This is a formula C. Right? You are writing exponential generating function. It is not the ordinary generating function. If you want to write ordinary generating function, then you have to include these constants. Right? This one. Here remember a0, a1, a2, a3 and so on are the real numbers. These are the what? Sequence terms of the exponential generating function of this one, right? a0 a1x plus a2x square by 2 factorial, a3 x cube by 3 factorial plus so on. That means we have to write the coefficient of x power 1 by 1 factorial, x power 0 by 0 factorial, x square by 2 factorial coefficient, x cube by 3 factorial coefficient, x to the power of 4 by 4 factorial coefficient we have to write, right? Now here general e power x formula, e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x4 bar by 4 factorial plus so on is equal to, here summation I running from 0 to infinity x to the power of I by I factorial, right? We are expressing this this series in terms of a summation, right? We are expanding this one by Maclaurin's series. Maclaurin is a scientist. By using his theorem concept, we are expanding e power x in terms of an infinite series, this one, right? Power series of x. Now e power x is the exponential generating function. Here underline this word, exponential generating function for the sequence. Here the coefficients I have to write, x to the power of 0 by 0 factorial coefficient is 1, x to the power of 1 by 1 factorial coefficient is 1, and x square by 2 factorial coefficient is 1, x cube by 3 factorial coefficient is 1, right? That means 1 comma 1 comma 1 so on. The function e power x is the ordinary generating function for the sequence 1 comma. Here if you want to write a generating function, then we have to write the coefficient of x power 0, x power 1, x power 2, x power 3 and so on. Once again I am repeating that one. If you want to write e power x as the generating function for this one, that means we have to write x power 0 coefficient, x power 1 coefficient, x power 2 coefficient, x power 3 coefficient. Here x power 0 coefficient is 1, x power 1 coefficient is 1, x square coefficient is 1 by 2 factorial, x cube coefficient is 1 by 3 factorial, x power 4 coefficient is 1 by 4 factorial and so on. That means e power x is the generating function, or more clearly ordinary generating function for the sequence 1 comma 1 comma 1 by 2 factorial comma 1 by 3 factorial and so on. Whereas if you want to write this one, e power x is the exponential generating function. If you add this word exponential generating function, then we have to write the coefficients of x power 0 by 0 factorial and the coefficient of x to the power of 1 by 1 factorial, x to the power of 2 by 2 factorial coefficient, the coefficient of x to the power of 3 by 3 factorial coefficients you have to write. All the coefficients are equal to 1. That is the difference. Now e power minus x is equal to 1 minus x. Now alternate signs, right? E power x is equal to this series we know, no? E power minus x is equal to alternate minus, right? 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus x to the power of 4 by 4 factorial minus x to the power of 5 by 5 factorial plus so on. Alternate signs, plus minus, right? Now if you add e power x and e power minus x, what you will get? 1 plus 1 is 2. This one x plus minus x is 0. X square by 2 factorial plus x square by 2 factorial is 2 into x square by 2 factorial. Next x cube by 3 factorial minus x cube by 3 factorial gets cancelled. X to the power of 4 by 4 factorial plus x to the power of 4 by factorial is 2 into x to the power of 4 by 4 factorial. Next term will be 0 and so on. That means e power x plus e power minus x is equal to 2 times of 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus so on, right? Now If you transpose this 2 to the left hand side, becomes e power x plus e power minus x by 2 is equal to 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus so on. Now, if you find the difference, e power x we know, e power minus x we know. If you find the difference of those two, see, e power x minus e power minus x. 1 minus 1 is 0. Plus x minus of minus x is plus 2x. X square by 2 factorial minus of minus this one is cancelled. X cube by 3 factorial minus of this minus becomes plus 2 into x cube by 3 factorial. X to the power of 4 factorial minus of x to the power of by 4 factorial is gets cancelled. That means you will get 2x cube by 3 factorial, 2x to the power of 5 by 5 factorial. That is e power x minus e power minus x is equal to 2 times of this one. If you transpose that 2 to the left side, e power minus x by e power x minus e power minus x by 2 is equal to x plus x cube by 3 factorial plus x to the power of 5 by 5 factorial and so on. Right?